All right, today we're talking about factoring. It's lesson 5.8, so the last lesson in chapter 5. Okay, last lesson in chapter 5. All right, so the first thing that we need to know when talking about factoring is this. First thing is finding the GCF. Okay. And the GCF we know stands for the greatest common factor. Okay. Or another way to put it is the biggest number that can be divided into everything. Okay, so the greatest common factor is the biggest number that can divide evenly. And you guys have done that before. When we talk about fractions, like simplifying a fraction, we're talking about GCF. So we've done that before, right? So here's an example. Let's say I have 8 over 16. All right, 8 over 16 is not simplified. Now, then we have a couple options. We say, well, what numbers go into both 8 and 16? Well, 2 does, right? But 2 isn't the biggest number. If we do 2, then we're going to have to go another step. Well, 4 does. Yeah, but 4 isn't the biggest number either. The biggest number that goes in both 8 and 16 is, of course, 8. The number can't ever be bigger than one of the original numbers. So we know that we can divide 8 and 8 on both sides, top and bottom, and end up with 1/2. This is because we use the greatest common factor. We didn't divide by 2, we didn't divide by 4, we divided by 8. 8 is the greatest common factor in that case, right? So let's go over how do we find the GCF in some of these terms, okay? So let's start with one like this. Okay, let's say we had 18 and 20a. Okay, so these are our two terms, 18, just a regular number, and then 20a. So this is how we're going to find the greatest common factor. Okay, this is one way. Some of you guys are like, well, you can just figure out what the factors are and things like that. So I think the best way to find the greatest common factor is to list out all the factors, okay, of these different things. Okay, so if I got 18, the factors of 18 are, well, 2 times 9, right? I got 3 times 6, and I've got 18 times 1, right? Like those are all factors of 18, right? Factors meaning like you can split them, like what times what makes 18. Okay, so 2 times 9, 3, 6, 18, 1. So all of these are factors. 2, 9, 3, 6, 18, 1. Well, what are the factors of 20? Well, I've got 2 times 10, and I've got 5 times 4, and I've got 20 times 1. Okay, and then I also have A, and A is there, but notice A, you have to multiply by A on all of them. So A is one of the factors. It's 20 times A. So A is a factor. That's the part that's a little bit confusing. The variables also count as factors. Okay, so now let's look at these, and which one do they have in common? What do they have in common? Well, we can kind of eliminate if you want. You say, well, 9, nope. 3, nope. 6, nope. They both have 18, nope. Now, they both have 1, but 1 is never the GCF because 1 doesn't do anything. So let's not worry about 1. 10, nope. 4, no. 5, no. 20, no. A is in there. So the only thing they both have in common is 2. So our GCF is 2. That's our greatest common factor. That's the only thing that we can divide into both. Okay? Let's have you guys try one here. Okay. Find the GCF. Let's see. So find GCF, and let's go with this: 12C and 36CD. Find the GCF. What goes into both of those terms? Okay, they're separate terms. I put a comma there to show that they're separate. Okay, what goes into both? The greatest number that goes into both. If you think you know it, you can put it in the chat. So again, you can kind of think of it as if they were fractions, like what would you divide both by? Think of the greatest number that you can divide by. All right, a lot of you guys putting there. Okay, so a lot of you guys are on the right track. You guys both know that 12, or you guys know that 12 is the greatest common factor for the numbers part, right? Because you could say, okay, this is 12 times 1, and this is 12 times 3. So 12 is there. Good. So my GCF is 12. But there's also a C in both. So that's also common. That's also on both lists, right? If I was to list them all out, C would be included. So the true GCF is not just 12, but 12C. Okay. We're going to deal mainly with the numbers on this lesson, but it's good to know that, like, hey, also C. But Mr. Long, what about D? Can I put D? Well, there's no D on the first one, so I can't put D. But there is a C on both of those, so we could say it's in common. Okay, it's a common factor. All right, let's go over now. We're moving on here. So again, being able to find that number 12, that's the most important thing. Being able to find. Now, some people said, what about 6, Mr. Leong? 6 goes into 12, 6 goes into 36. No, but we're looking for the greatest common factor. The number that goes in, that's the biggest. Okay, the biggest number that goes in. So 2, yes. 6, yes. But we're not looking for the smaller ones. We're looking for 12, the biggest one. Okay, 12 is the greatest common factor. Not just a common factor, greatest. Okay, so now let's get into the kind of the meat of what today's lesson is and what your IXL will be, which is factoring, right? So what is factoring, okay? Well, factoring, actually, we just did a whole lot of factoring. Factoring is just saying, what are the factors of what we started with? Like, what can you multiply to get there? And you guys remember those factor trees? Some people really like those factor trees where you just break things down, break things down, break things down. Okay. So here's an example. Just watch. You don't have to, don't write this down. So for example, if I want to know the factors of 6, well, I could say that breaks down into 3 times 2. Okay. So there's a question about why is there a C again? These are just different terms. So going back to letter B, again, if you think about it, this is 12 times 1 times C. And this is 12 times 3 times C. So what's in common? The 12 is in common, and the C is in common. So that's why it's 12C. Don't stress about that too much. Okay, moving on. Today what we're going to deal with is, what about, like, if you had something like this? And again, don't write this down. And I said, what are the factors of 3x plus 9? Well, what you're going to do is you're going to break this down similarly to how you broke down the 6. What times what equals 3x plus 9? What's going to happen is this. You're going to end up with 3 times 1x plus 3. Huh? Don't worry. We're going to get into that and practice that today and tomorrow. Okay. What you're doing really is, it's kind of basically like the opposite of the distributive property, right? If you think about it, the distributive property is where you multiply. Factoring is when you go the other way, right? You break it apart instead of putting it together. So let's do an example here together, because I know this is a little bit confusing. Okay, let's say you had this, and I want you to factor 4x x minus 28. Okay, so first step. What is the GCF? What is the greatest common factor between these two terms, 4x and 28? What number goes into both? Okay, now we know only one of them has an x, so it doesn't have to involve x. So what number goes into both of these, okay, and is the greatest common factor? Okay, 4, good. You guys put in the chat 4. Now 2 does, but again, we want the greatest common factor, okay? 7 does not go into 4, right? That's a good question, right? Someone put in there was about 7. No, 7 doesn't go into 4, right? It has to go into both numbers. So 4 goes into both. So this is what I'm going to do. Follow along with me. I'm going to pull a 4 outside, and I'm going to put blank parentheses right here. Now check this out. This is pretty cool. All right. You can think of this as two ways, right? You can either think of this as division or, what do you need to multiply? So let me ask you this. Divide 4x divided by 4. This part, 4x divided by 4. Or what times 4 gives me 4x, right? Well, think about it. 4 times x gives me 4x, right? And think about it this way. 4 times what gives me 28? Or 28 divided by 4 is equal to 7. And then the minus is right there. So this is the factored form of where I started. Okay. So again, what am I doing? It's kind of like saying, again, look at this example right here. 6 can be broken into 3 times 2. So I'm just saying 3 times 2 is equal to 6. I'm saying the exact same thing right here. I'm saying 4 times x minus 7 is equal to 4x minus 28. And let me prove it to you. This is how you can prove that you did it right. Check it out. I can take this example here. And if I distribute it out, I should get back to my original problem. 4 times x is 4x. 4 times 7 is 28 with a minus there. So it works. I checked out. You guys see that? Just like if I do 3 times 2, I do get 6. 3 times 2 is equal to 6. Okay, so I know this is a little bit tough, but we're going to get the hang of it, okay? Don't worry, we're going to work together and get the hang of it. All right, let's do another one here. Nice and easy. 3x plus 15. Let's factor that. Can you factor it so that can you factor this expression? So 3x plus 15. I've got two terms there. I've got 3x and 15. Yep, there you go. Good, Jeffrey. So again, the first thing you want to do is find the GCF and then pull it out. Okay, again, it's kind of like distributive property in reverse. All right, anyone else want to give it a shot? Go ahead, put it in the chat. Yep, that's good, Kelly. Yep, that is the GCF. Okay. No, so I don't want just the GCF. I want the whole thing. Yeah, Alondra, that's good. Nee, that's good. Yeah, Wilson, that's good. Yeah, you guys are starting to get it. Okay, good. So I'm going to pull out the GCF, which is 3. 3 goes into both. I'm going to put my open parentheses, and then I'm going to fill it in. 3 times x gives me 3x. 3 times what gives me 15? 3 times 5. And that's it. There's your answer. Okay. So I pull out, you know what I'm saying? I like to think of it as I'm pulling out that 3 and I see what's left. So if I divide this by 3, I end up with x. If I divide that by 3, I end up with 15. Right? And for the IXL, that's basically what you have to do. On some of them, you have to see if things are factors. Basically, does it divide into? So on the IXL, it doesn't even ask for GCF, but I like to do it. Okay, let's do another one. Okay, how about this one? 8x plus 12. Okay, 8x plus 12. Can you guys factor that one? Good, Jeffrey. Yep. Yep, that's it, Jenny. Good job. Almost knee. Double check. And again, if you distribute it and it doesn't come out to the original, then you know that something went wrong. So remember, make sure you're pulling out just the GCF. It's close. Okay. All right, so let's think about the GCF. Now, some people are trying to do 8 as the GCF, but remember, 8 does not go into 12, right? 8 doesn't go into 12. So I can't use 8 because 8 doesn't go into 12. So that doesn't work. So I can't use 8 on this one. Remember, I had to find my GCF, okay? So my GCF in this case is, as you guys know, 4. Good. Okay, so how do I get from 4 to 8x? Or 8x divided by 4 is another way to put it. Okay, that's going to be 2x, right? Oh, I can do that? Yeah, sometimes you're just putting the x, but 4 times 2x is 8x. Good. And then 4 times what is 12? 4 is 3. And there you go. Now, let me show you one way that some people do this wrong. Let's say you're like, oh, Mr. Lang, I know that 2 goes into both of those. So I'm going to do it wrong right here. So don't write this down. Just I want to show you. If you take out not the GCF, okay, so a number that's too small, so not the greatest common factor, just a common factor, you'll end up with this, 4x plus 6. If you can still factor the inside, you didn't factor it correctly, right? Because that means that you can keep going another step. So this is wrong. Like if you can still factor this part, then that's bad. Okay? Notice I cannot factor 2x plus 3 anymore. There's nothing that goes in 2 and 3. I cannot factor x and 5. There's nothing that goes into both x and 5. I can't factor x and 7. There's nothing that goes in there. So that's why it's really important to pull out the GCF first, the greatest common factor. All right, let's try another one. Let me just one more. And again, we're going to go over this more next day, but this is primarily what we want to focus on today. Here's one a little more challenging. (14x minus 16y). 14x minus 16y. Try to factor that. Put that in the chat. This one's a little bit more challenging. There's some like this on the IXL. Good, Jeffrey. Good. You guys are getting it. Yep. Nia, that's good. Almost. I think on some of you guys. Yeah, most of you guys are getting that. Yeah, most of you guys are doing a good job with that. Okay, so Most of you are saying, okay, the only thing that goes into 14 and 16 is the number 2. So this is going to be 7x, and this is going to be 8. Now, make sure you put the y. Sometimes people forget that. And then also, this is a minus, so just keep the minus. You don't have to worry about keeps with change. You don't have to worry about adding or subtracting, but make sure that stays as a minus right there. Some people put a plus accidentally in there. Okay, and that's it. That is a fully factored expression. Okay, you're just breaking it apart. It's kind of like, I don't know if you're like me. If sometimes I'm like, I have a pen and I'm playing with it, and I just want to, like, you take off the cap and you start unscrewing stuff, and for no good reason, just because you like taking it apart. That's what we're doing here. You're just kind of taking it apart. You're gonna fiddle with this expression and break it up into its smaller pieces. All right. Okay. So going back. Okay. So remember, the key here is finding the GCF. First step, find the GCF. A lot of times it's the first number or the smaller number, but sometimes it's not, right? And again, you want to find the GCF, the greatest common factor, and then you just kind of pull it out. And then you can remember, you can always double check to see if you got it right by distributing out. Okay, distributing out. So for example, if I go to this one and I want to double check, I could say, okay, well, 2 times 7x minus 8y. Let's distribute. 2 times 7x is 14x. 2 times 8y is 16y with a minus in the middle. And look, we got what we started with, right? That's how we check it. So pretty good.